On this first part, we're just going to go over, if I give you three side lengths, first of all, how do you know if it's a triangle or not? We talked about that before. But then, how do you know what kind of triangle it is? Meaning, is it a right triangle, an acute triangle, or an obtuse triangle? So we're going to, when I go over this, we're going to assume that C is the largest of the three sides, okay? So first of all, if I give you A, B, and C, so three numbers where C is the largest number, how do we know if it can make a triangle or not? This is review. Yeah. So use A, B, and C, because C is the largest side. So it's not a triangle if A plus B is less than or equal to C. That kind of what you said in a different way, but so if A plus B is less than or equal to C, then it's not a triangle. Okay, that comes from the triangle inequality theorem, and we've seen that. What if it is a triangle now, and it meets that requirement, but now we need to know if it's a right triangle. What do you think the relationship has to be between A, B, and C if it's a right triangle? So if A squared plus B squared equals C squared is true, then it's a right triangle. And that comes from the Pythagorean theorem. It's actually the converse of the Pythagorean theorem. Okay? So if we have, so let's set this up here. So here's a little picture here. We know that here's A and B and C. So if A, B, and C are side lengths of a right triangle, we know this is true. Okay. Well, what if we keep A and B the same length, but we extend the length of C? Is this still going to be a right triangle? No, not anymore. What kind of triangle would it be if I grew that C? Yeah, obtuse. Because in order to accommodate that larger C, you'd have to stretch out that angle bigger than 90 degrees, and you get so here's A, B, and C. So this is an obtuse triangle. And so what would happen, like if I found A squared and B squared and compared that to C squared, which side would be larger? So the A squared plus B squared, I didn't change A or B, they stayed the same. So that's the same value as the first one. But I did increase C, so C squared is now even bigger. So we have A squared plus B squared is going to be smaller than C squared. And so this is always the case. If you find A squared plus B squared and get that C squared is bigger than that, then you're going to be working with an obtuse triangle. Okay, assuming it's a triangle. Okay, and then lastly, if we were to make an acute triangle, I mean all three angles are smaller than 90 degrees. Sorry, should be an A. So A, B, and C. What do you think we're going to find if we calculate A squared plus B squared and compare it with C squared? So A squared plus B squared is going to end up being more than C squared because we've decreased the size of C to create this acute triangle. And so that is our criteria for determining or classifying what kind of triangle we're working with. So at number one here, we have, well, our directions say first, make sure it does form a triangle, right? So C is our largest side. If I add a and b together, is it going to be bigger than 9? Yes. So it is a triangle, so I'm not going to go with that one. So then, after that, then we're going to check out a squared plus b squared, so 3 squared plus 7 squared, and compare that to 9 squared. So 3 squared is 9, 7 squared is 49, 9 plus 49 is 58, and 9 squared is 81. And so 58 is less than 81. And so what does that tell us about the triangle? It's going to be an obtuse triangle. We try it on number 2, which is 20, 21, and 29. First of all, is it a triangle? Yeah, because 20 plus 21 is bigger than 29, so we're good with that. So now it's either an acute, right, or obtuse. So find 20 squared plus 21 squared and compare that with 29 squared. And you're welcome to use your calculators on this one, if you brought it. Keep the cell phones away. And what's 20 squared plus 21 squared? 841. And what's 29 squared? 841. So what does that mean? It's a right triangle. Okay. All right, so finish it off. Do 3, 4, 5, and 6. They're not too difficult of problems. Give them a try. Okay, so what do we get for 3? 3 is not a triangle because 4 plus 11 is less than 16. Number 4 is acute triangle. Number 5, a right triangle. And number 6, not a triangle. Okay. So anyhow, that's just want to make sure you're aware of how you can classify what kind of triangle you're looking at using the Pythagorean theorem. Okay. All right. Let's now take a look at the law of cosines. So just as we came up with the law of sines, and I kind of worked through that one with you and showed you where it came from. Today I'm just going to give you the law of cosines because you need more information, more background for the proof of this, which you will get probably around February. So you just don't have the background for me to show you the proof of this. So you're just going to have to accept right now what the formula is, okay? So here's what it is. So say if you're looking for, maybe you have 3 side lengths, A, B, and C, and maybe you're looking for this angle here, okay? If you're looking for that angle, then you're going to start with the side across from the angle. So A squared is equal to B squared plus C squared minus 2BC cosine of angle A. All right, so it's a lot of stuff coming from somewhere, right? But this would be the law of cosine in that form, and there's a pattern to it. Say we weren't looking for angle A or using angle A. Say we're using a different angle. Say we're working with angle B. So then I would start with B, and I'd write B squared equals. See if we can figure out this pattern. A squared plus C squared. Okay, good. Minus 2AC cosine of angle B. Good. So write what the third one would be if you started with C squared. So if you're working with angle C, you're going to start with side length C. And you get A squared plus B squared minus 2AB, and it's the cosine of angle C. Using this proof, like if I were to show you the proof, what are some of the things you think I would use in the proof besides cosine? Maybe see where Pythagorean theorem might have a play in this. We got the A squared plus B squared equals C squared idea happening here. So the actual proof uses Pythagorean theorem and mixed with cosine, and this comes out. But there's some trig identities that you'd have to know, and we haven't talked about trig identities yet. But let's apply this, okay? So when you're working with a triangle, so first of all, if it's not a right triangle, if it's a right triangle, different method, right? But if it's not a right triangle, then you try. First thing is law of sines. It's easier to remember, easier to work with. See if it works. Would the law of sines work here? Well, you try it out. You say, well, the sine of 65 over x equals, and then you're stuck because you're like, I don't know any other angles here, right? All right, so law of sines doesn't work. Then you try law of cosines. For the law of cosines, you focus on what angle you have first, and then you're going to use the side length across from it. So we're going to start with x squared equals 7 squared plus 12 squared. Kind of a Pythagorean theorem setup, although doesn't have, it may not be the longest side. Sorry, then minus, not equals, 2 times 7 and 12, and then cosine of that angle that we're working with, 65. Okay. So notice that everything on the right side of this equation is something you can plug into a calculator. There's no variables on the right side. So you could just plug that whole thing in, or you could do a piece at a time, but I'm going to plug it all in. So you should get 122, roughly. It's rounded, and then you're going to take the square root of that, and you get about 11, right? And so we've used the law of cosines to find that missing side length. All right, so I think the toughest part of this is just to memorize the formula, right, or the law of cosines. So try it on number 2. It's very similar. You're getting something different than I am. What you're saying? So what are we getting, guys? 36.5. That's what I'm getting to, 36.5. All right. So, yeah, calculator issues, I'll help you out with that. No problem. Okay, so if you had a calculator issue, I'm going to help you out, but let me introduce number 3. Okay, number 3 is a real troublemaker for most people. Okay, so it's still the law of cosines, but here we're not solving for a side length. We're going to solve for an angle, and you need to be very careful here. So here's the angle that we're interested in, and so we're going to start with 7. So 7 squared is equal to, doesn't matter, 12 squared plus 11 squared, I'll do that in order, minus 2 times 12 times 11 cosine of x. And you have all the tools that you need to solve for x. It's just people have trouble solving for x because they're not sure how to follow the order of operations here. So that's all I want to say. I want you to try it, get an answer for x. If you had trouble with your calculator on number 2, I will be walking around and let me know and I can help you out, okay? Okay. So 7 squared is 49. These are like terms, so I'm going to square them and add them. And what do we get? What's 12 squared plus 11 squared? 265. Okay. Then this, all this right here, belongs to the cosine of x term. And if you multiply all that together, I think it came out to 264. And I know you're tempted to subtract 265 and 264, but you can't. Because they're different terms. This goes together. Okay? And so our goal here is to get cosine of x by itself. So I need to get rid of the 265 somehow, and I need to get rid of the 264 somehow. Any ideas? Subtract what? From both sides of the equation. So you want to subtract 265 from both sides. So this is 0. And what's 49 minus 265? Negative what? 216. Okay, then how do we get rid of the negative 264? You don't add, because it's held together by multiplication. You divide both sides by negative 264. So you get negative 216 divided by negative 264 is equal to cosine x. Now we're almost there. We want x by itself. So what are we going to do? Inverse cosine of, and you could keep them both negative, or negative divided by negative is positive, so you could just change it to positive 216 over 264. And now you've typed that into your calculator. And 35.1. Did somebody have that already? All right, all right. Okay, so do number 4. It's like this one, and now let's do it the right way, okay?